Welcome to your regex, DLP, and PowerShell community. Today's topic is DLP. Data loss prevention or data leak prevention. Here is what 90% of companies get wrong. Let's bring up two examples. Example 1. Company loses all customer data in ransomware attack. Example 2. Healthcare data of 10 million patients leaked online. Which one is a leak and which one is a loss? Pause if it's needed. Two data disasters. But they are completely different problems requiring different solutions. Yet most companies treat them the same. Data loss is when data becomes unavailable or destroyed. It's gone. Vanished. No one has the data anymore. It can happen when hard drive failure with no backup, accidental deletion of critical files, ransomware encrypting your database, natural disaster destroying servers. Data loss is actually availability problem. Data leak is when data goes where it should not, but still exists somewhere. It's in the wrong hands, but it's not gone. It can happen when employee sends an email including email's customer list to personal account. Developer uploads source code to public GitHub. Hacker exfiltrates database to their servers. Misconfigured cloud storage exposed to internet. In this video we are going to cover the data leak prevention. I start by explaining the different data type. In the realm of DLP, there are three types of data. First, data at rest. Second, data in use. Third, data in motion or transit. I found an interesting example on internet which is a business analogy. At rest equals money in the vault. In use equals money on the teller's counter. In motion equals money in the armor truck. Data at rest refers to as persistent data, stored on physical or virtual media in a non-volatile state. This data not currently being accessed or transferred, residing in storage systems waiting for future use. The data at rest can be at user workstation, servers, cloud environment. Here are the risks associated with data at rest. Physical theft of storage media, unauthorized database access, ransomware encryption attacks, backup compromise. Data in use refers to data actively being processed, accessed, or modified by applications, users, or systems. This is data loaded into memory, displayed on screens, or undergoing computational operations. Some business examples includes CRM system with customer records open, ERP software processing financial transactions, HR system showing employees' salary information, accounting software generating financial reports, project management tool displaying strategic plans. Here are the risks associated with data in use. Screen capturing, memory scraping, unauthorized copy-paste, malicious insiders, and printing. Data in motion, also called data in transit, refers to data actively traversing networks between endpoints. This includes internal network transfers, external communications, and cloud-to-cloud data flows. Examples can be API calls, email attachments and file uploads. Here are the risks associated with data in motion. Man-in-the-middle attacks, protocol exploitation, DNS poisoning, data interception. What I just presented is a very high-level view and it can be broken to many categories. My goal is to build a foundation, so when you start working with a DLP solution, you can understand the features and tools it offers for different type of data. Let me give you a real-world example. In Zscaler, one of the well-known DLP solutions, their greater focus is on data in transit. They call it ZTNA. It eliminates man-in-the-middle by implementing secure connection between endpoint and their zero-trust exchange servers or systems, and on top of that, they create a micro-channel which replaces the VPN connection. All endpoint IP addresses are fake, and by that I mean they are not part of your organization IP addresses, which eliminates the greatest threat which comes from IP address exposure. In Microsoft Purview this feature doesn't exist yet and may never be built. In most if not all DLP solutions, they have options to eliminate the threat on all three types of data I explained earlier. DLP is a broad subject. Mastering all aspects of DLP is almost impossible for a single person, but having a solid understanding of the idea behind it will make your journey much easier. Going forward, I intend to explain some DLP features, which are supported almost by all DLP solutions. Before I begin, I need to explain three key elements. First, where the user can be. Second, how many different access we provide which matters in DLP. Third, SaaS or software as a service. First, let's see where account or user can be. The diagram shows where account or user might be in your organization. I'm certain that you have a very good idea about your own organization accounts and location. Understanding different accounts and access is a key to what I am going to explain next. Second, accounts and access types in an organization. Our focus is on three categories of access: internal, external and accountless access. Internal accounts. Internal accounts includes full-time employees or permanent staff with HR life cycle, extended workforce or contractors, interns, temporaries, service accounts or app-to-app integrations, API keys. Please pay attention to their SaaS access method. Theoretically, they can access everything local or on the cloud. External accounts. External accounts includes business partners such as vendors, consultants, system integrator partners. Customer accounts, such as external clients using your SaaS. Guest collaborators such as project-based external users. Non-interactive and special accounts. System accounts such as built-in OS and app local accounts. Bot or automation accounts such as RPA, scripts, scheduled jobs. Test or training accounts for non-prod environments. SaaS-specific local accounts, they are created directly in SaaS. Third, what is SaaS? SaaS or software as a service is a specific business model for consuming ready-to-use, subscription-based software over the internet, while a cloud app is any application hosted on remote servers. You can say cloud infrastructure. All SaaS is a cloud app, but not all cloud apps are SaaS. Now that user location, account, access types, and SaaS is covered, I like to start with a term called CASB or Casb. It's short for Cloud Access Session Broker. Microsoft calls it Cloud App Control, Zscaler calls it ZIA, Netscope calls it Netscope One Security Service Edge or SSE. Casb can be implemented in three different methods which I will explain later. At a very high level, we can divide the Casb into two major categories: inline Casb and out-of-band Casb. Why we use Casb is the key to understand this technology. We use Casb to enable secure cloud adoption by providing visibility, compliance and data security, threat protection for cloud services while balancing security requirements with business agility and user productivity. Once again, all these can be broken down and discussed in more details, but let's stick with these for the sake of this session. Based on what we covered about user location, users can be inside or outside of the organization and their devices can be managed or unmanaged. In summary, we have internal users with managed devices. We also have external users with managed devices. And finally, we have external with unmanaged devices. Here is the core idea in any DLP solutions: forwarding all the inside and outside traffic to DLP engine, regardless of their location and their device type. I repeat, forwarding all the inside and outside traffic to DLP engine. No data traffic can avoid the DLP core. What I said needs time and efforts to fully understand, otherwise we see a door with many locks, some doors with only one breakable lock, doors with no locks, and believe me when I say it, no door at all. You may laugh, but I have seen international organization spending millions on cybersecurity with no door to their critical and sensitive data. The sad part is that they're cybersecurity architects. You heard that right, architects are struggling to understand the basic DLP concepts such as inline and out-of-band Casb. I go back to the different way of Casb implementation. It will give you a better understanding. There are 3 methods to deploy Casb. This is the best diagram I found on internet. Please take your time and go through all elements. As demonstrated, all type of users and devices are going through Casb for inspection and protection. Let's explain each method. Method 1, Reverse Proxy, Inline or Gateway. Also known as Gateway-based Casb. Position, between users and cloud apps. How it works, primarily for unmanaged or BYOD devices, offering agentless, real-time control over sanctioned SaaS apps. Here is more detail about Reverse Proxy. Sits between the user and the cloud service, such as Salesforce or Office 365, without requiring an agent. It is ideal for unmanaged or third-party devices, allowing companies to restrict actions like downloads or printing when employees access corporate apps from personal devices. Method 2, Forward Proxy, Inline or Outbound. Also known as Outbound Proxy Casb. Position, between enterprise network and internet. How it works, typically for managed devices, acting as an agent-based intermediary for real-time traffic, especially for SaaS and web traffic. Here is more detail about Forward Proxy. It requires an agent installed on the device, laptop or phone, to route traffic through the Casb, allowing for real-time inspection, data leak prevention, DLP, and shadow IT discovery. It is best suited for company-issued devices, as it requires control over the endpoint. Method 3, API-based, out-of-band. Also known as Cloud API Integration. Position, direct integration with cloud app APIs. How it works, for all devices and users, providing deep visibility and data at rest protection, DLP. Directly integrated with cloud services, though not in real time. In the other word, API-based Casb. Connects directly to the Cloud Applications API, cloud applications such as Google Workspace, Microsoft 365, to scan for data at rest, identify, and revoke public links. It provides continuous monitoring regardless of the device, making it essential for covering all environments. Pay attention to the words inline and out of bands. Inline means real-time traffic inspection anywhere. Out of band means post-event analysis anywhere. I give you few analogy to understand between inline and out of band Casb. Inline Casb means security guard at front desk. Checks ID of everyone entering or leaving. Can deny entry right at the door. Misses, back doors, windows, deliveries. Out of band Casb equals security cameras system. Records everything happening everywhere. Reviews footage after incidents. Can see all entrances, but cannot stop crimes in progress. In any organization you need both technologies, together. They can safeguard your data. Each solution has pros and cons and can miss something. Let's see what inline Casb, in other words forward and reverse proxy, can miss. Direct app to cloud connections bypassing proxies. Native clients connecting directly to SaaS APIs. Automated cloud data replication. Data already in SaaS before deployment. Historical data, past uploads/downloads. Cannot delete existing data, only prevent new uploads. Cannot modify stored data, only block in transit. Cannot revoke access, only prevent future access attempts. Now time to see what out-of-band Casb cannot do. Stop data as it leaves, only finds it after arrival. Prevent initial exposure, data already breached before detection. Provide immediate alerts because of delayed notification cycles. Control all data types because it's limited by SaaS API permissions. Monitor encrypted traffic. It has no SSL/TLS inspection capability. Handle custom applications that can only act on standardized SaaS support. Provide complete forensics, limited to API available data. Ensure real-time compliance, only retrospective compliance. You need out-of-band Casb when you have BYOD or unmanaged devices. Employees work remotely or travel frequently. Business uses sanctioned SaaS applications. You need to find data already in the cloud. You require comprehensive compliance reporting. You need to remediate existing data exposures. You want to monitor cloud-to-cloud data flows. Legal and privacy restrictions limit inline inspection. You need complete visibility, not just prevention. The bottom line is that out-of-band Casb is a detective control that finds problems after they happen. It cannot prevent problems as they happen. You need inline Casb for prevention and out-of-band Casb for complete visibility, which brings you total cloud security. The complete model is called multi-mode or hybrid Casb. Most modern, comprehensive security strategies use a combination of all three approaches to ensure full visibility and control across managed, unmanaged, and data-at-rest scenarios. This wraps up the DLP introduction and Casb session. Until next video. Ciao.